Here's another question that deals with stoichiometry and practicing calculations. It also deals with theoretical yield and actual yield. So the question reads as follows. The gaseous hydrocarbon acetylene used in welders' torches burns according to the following equation. So if acetylene plus oxygen gives us carbon dioxide and water, the equation is balanced for us, and it says, what is the theoretical yield in grams of carbon dioxide if 22 grams of acetylene completely reacts? So what I'm going to start with is my 22 grams of acetylene. So if I have 22.0 grams of acetylene, C2H2, I can go over to my periodic table. I can add up the atomic mass of 2 carbons plus 2 hydrogen, which gives me a molar mass, or a molecular weight, of 26.04 grams of acetylene for every 1 mole of that molecule, acetylene. But it's asking me, what's the theoretical yield in grams of carbon dioxide? If I was to just end my problem right here, you can see that grams of acetylene are going to cancel out. I'd be left with moles of acetylene. So I'm not at the end of my road. So if I again go up to my balanced equation, I can see that for every 2 moles of acetylene, I make 4 moles of carbon dioxide. So I can use that as a conversion factor to figure out how many moles of carbon dioxide will be produced. So I'll put 2 moles of acetylene in my denominator here, and in the numerator I'll put my 4 moles of CO2. So again, if I was to stop here, you can see that moles of acetylene cancel out, and I would end up with the number of moles of carbon dioxide. But again, I haven't reached my my ultimate goal, which is to figure out the number of grams of carbon dioxide. But to do that, I just need one more conversion factor, and I know that for every 1 mole of CO2, I already calculated the molar mass. It's 44.01 grams of CO2. Then you can see that the last units, let me get my red pen here, you can see that moles of CO2 cancel out, and I'm left over with grams of CO2. And the number of grams is 74.4 grams of CO2. I just have to kind of write it on an angle like that. Okay, so I get 74.4 grams of CO2. So Part B says the actual yield, so what the chemist actually isolated was 64 grams of CO2. Nothing ever works according to plan, right? So based on the balanced equation, and if everything had gone perfectly, if the combustion was complete, we would have gotten 74.4 grams, but instead they got 64 grams of carbon dioxide. So it says, what's the percent yield? So the formula for percent yield is simply the actual mass obtained divided by the theoretical yield. So theoretical yield is in an ideal world. This is the theoretical yield. That's what we should have obtained. So if we just put those numbers into the equation, we get the percent yield is 64.0 grams divided by 74.4 grams. So grams and grams are going to cancel out. Percent yield will be expressed as a percentage. We end up with 86.0%. Still not too bad. That's pretty good. So hopefully this helps you with stoichiometry and calculating percent yield.